In this lesson, we will see how to convert a number from decimal number system to binary number system. Now, converting a number from decimal to binary is essentially finding all the digits of the number in its binary representation. Let us first see how to find the digits of a number in its decimal representation, and then we will come back to binary. So if I write a number in decimal number system, the rightmost digit corresponds to ones position. And then we have tens position, hundreds position, and we go on in powers of 10. Now if I write a number in decimal number system, say for example 125, then let's look at it this way. 125 has actually got 125 ones. But we do not write all these ones into the ones column. What we do is actually take out all the tens from these ones and keep only the remaining ones in the ones column. So we say that 125 ones is actually 12 tens and 5 ones, and only this 5 goes to the ones column. Again, we cannot keep all these 12 tens into the tens column, so we take out all the hundreds out of this and keep only the remaining tens in the tens column. So this goes here. Now we cannot take 1000 out of this 100, so all of this 100 actually goes to the hundreds column. So if I have the number 125, if I divide it by 10, I get 12 as quotient, which gives me the number of tens, and 5 as remainder, that gives me the remaining ones. And if I pick up 12 tens, then again division by 10 gives us 1 as quotient, which is the number of hundreds, and 2 as remainder, which is the number of remaining tens. Now dividing 1 by 10 gives us 0, which is the number of thousands, and again 1 in the remainder, which is the number of hundreds. Now if you can see, this whole process is actually giving us all the digits of the number, starting from the rightmost digit to the leftmost digit, and if we go in the remainder column from bottom to top, we get the number, or rather the digits of the number, from left to right. If we say that this leftmost column is n, then the quotient can be obtained by n by 10 and picking up only the integral part of it, and the remainder can be achieved by performing an n modulo 10. Now if you can see, then we have actually devised an algorithm here to convert a number n to its, or we should say actually to find out all the digits of the number n. Now we will quickly write a pseudocode for this. I will write a method find digits in decimal that will take an input n and give me a list of all the digits in the decimal representation of the number. So we will start with an empty list, and we will keep filling the list as we find out all the digits. So this list in an actual program could be an array of integers or an array of character or whatever suits you. And the program goes like, while n is greater than 0, perform a modulo by 10 and store the value in a variable called remainder. Now this remainder is actually the digit in the first go, the rightmost digit. Now add this digit to the list, so we'll say that list is now list plus remainder. Now we reduce n to n by 10, and if n is an integer, this will always give us the quotient. Now when we get out of this loop, we get a list of all the digits of the number in its decimal form, but we get this list from right to left, and we write a number from left to right, so we could reverse the list to get the number or the digits from left to right. So we'll say that reverse the list. Now converting a number from decimal to binary is nothing but finding out all the digits of the number in its binary representation. Now as we know, in a binary number, the rightmost digit corresponds to ones position, and then we have 2s, 4s, 8s position, and we go on increasing in powers of 2. So to find out the digits, we will do something similar to what we have done in the left. We will write, or rather create, two columns here, quotient and remainder. Now we start with 125, so initially we have 125 ones, but we cannot keep all these ones into the ones column, so we take out all the 2s, and this time we need to divide by 2 to take out all the 2s. So this gives us, the quotient gives us 62 2s and remaining 1 ones. Now this one goes to the ones position here. Again we have 62 2s, so we need to take out all the 4s from this, so we again divide by 2, we get 31 4s and remaining 0 2s, and this goes to the 2s column, and we go on like this. So if we say that this particular column, the leftmost column, is n, then the quotient can be calculated as n by 2, and we take only the integral part of it, and the remainder can be calculated by n modulo 2, and we can keep on going and filling the digits from right to left. And we stop once we get a 0 in the quotient. So now we can see that the remainder from bottom to top is actually giving us all the digits of the number in its binary representation. So we can say that the number 125 in base 10 is actually 1111101 in binary or base 2. Now let's quickly write a program for this as well. The program is pretty similar to finding the digits in decimal, except that this time we are finding the digits in binary. So we'll say that find digits in binary. Or if it suits you better, we will rename the method as decimal to binary. So we will again start with an empty list and try to fill this up with the digits in the binary form. And this time we'll say that while n is greater than 0, calculate the remainder by performing a modulo by 2, and then add this to the list. And this time we reduce n to n by 2, and if n is an integer, this gives us the quotient. Finally, we again reverse the list because we need digits from left to right. So this pretty much gives us a code to convert a number from decimal to binary, and this will work fine for all positive integers. N is equal to 0 is however a special case which we have not handled well, because in that case the list will remain empty because the control will never go into this loop. You need to handle it gracefully in your actual program, and I'll leave it for you to do it. Now this also gives us a generic algorithm, kind of a generic algorithm to find out a number in any base p. So if you want to convert a number from decimal to base p, all you have to do is, instead of taking a modulo by 2 here and a division by 2 here, we divide by the number b and take a modulo by b, and this will give us the number in any base p, and you should be good. So thanks for watching.